Hello, everyone. Am I audible? Perfect. Hello, everyone, and I hope you enjoyed your lunch. And today we're going to talk about LLM, large language models in testing. And we're going to cut a little bit through the hype around LLMs. If you have LinkedIn, which I'm sure you all have, you probably have anywhere from 20 to 50 links that you promised yourself you're going to read at some point because someone wrote a very nice post about LLMs, AI, and what it can do for you, right? Personally, I have like 50 of those, which I never had the time to, found the time yet to read them. So, or I should point there, perfect. Like this. So we're living in exciting times where we're seeing explosion of innovation powered by LLMs, particularly around the application development and software test application. It seems that every week there is a new announcement of flashy product or flashy demo that is promise us the world. But how much of it is really actually useful for test automation, and how much of it is just an hype? In this session, we will talk exactly about this. So let's start by talking about the current state of test automation. As you all know, in the recent years, there has been an exponential growth in the complexity and the scale of software. Applications are getting bigger and bigger, and companies building more and more of them. The user experience gets more and more complicated, and hence, far more difficult to actually test them. On the other hand, teams are releasing features or required to release features faster than ever. And to do that, guess what? With less budget. OK, I got this now. This is the button, not the left one. All right. So, and now I got it. So what we hear from from teams all around the world, from our customers, and from the research that we've done on ourselves, is that actually traditional approach for testing doesn't scale. There are probably the number one factors for productivity loss, velocity loss, and hence increased cost. As the traditional approach to test automation failed to keep up with growing complexity of modern software, the industry responded by shifting ownership left and left and left. It's easy to see why the industry embraced this approach of shifting left. It promotes the value of engineering, building features that works. It promised earlier detection of bugs and tighter feedback loops, encouraged building testable application, and also avoid introducing automation breaking changes. Unfortunately, shifting left doesn't solve the core issue. Whether you are an application developer or a test engineer, at the end of the day, you still need to write a lot of code, which introduces us to the following four factors: that writing this code first is being done by limited manpower, people who know how to write code and have coding skills. Hence, they have a major maintenance burden. Major maintenance burden because the fragile locators, at the end of the day, we need to maintain them down the road of testing. It creates a velocity loss every time that the developer is required to write tests and to do context switching from building the app to writing the test. It's actually time that they are not spending on writing new features. And it also introduces a never-ending conflicting in priorities because in most cases, developers are measured by features delivery and not necessarily by testing coverage. So at the end of the day, we're finding ourselves in a loop where we are constantly chasing our own tail. As teams discovered that shifting left doesn't solve the problem, they turned to the new wave of AI innovation that promised them the world. Putting aside vendors adding prompts to their legacy testing tools to check the marketing box that their tool is AI-powered, most current AI tools focus on helping developers to write more code. But do they really solve the problem for automation? When we review code-centric tools such as GitHub Copilot, Playwright, Selenium MCP, or LLM-powered IDEs such as Cursor, or direct code generation platforms such as ChatGPT, Claude, Gemini, and others, what we are seeing is that they are really good in generating, they are not so good, sorry, in beyond unit testing. They are far better in authoring new code rather than editing a code. They're really, really struggle with assertions. They're doing first grade schools assertions most of the time. And at the end of the day, code generating tools demand constant developer oversight. If code is the problem, why not to use LLMs to run the test without code, right? The idea sounds very appealing. Let's describe the test scenario, put it into a prompt, and get a tool to do it for us. Some tools and fancy demos promise just that. AI that drives the UI and validates functionality on its own given test goal. But would you trust an AI to make up test steps live during each run? Would you trust it not to hallucinate or skip important actions? Would it really catch bugs instead of working around them? Would you accept no ability to debug or fix test failure? Would you accept multi-seconds delay between test steps? And above all that, will you pay all those billions of tokens that it will consume? I guess the answer that for all of you is no. No chance. Let's be honest, we cannot compromise on the fundamentals of testing, which are stability, determinism, and speed. They are not optional in automation. They are essential for effective testing at scale. And LLMs, at the end of the day, they are statistical models. They do not provide the consistency and determinism that we need. So if traditional approach doesn't work, what should we expect from the next tool, the AI tools that we are going to see in the upcoming future? We would like tools that will allow us to attain near complete test coverage. Nowadays, most companies admit that they coverage around 20%, where we would like to have over 80%. We need tools that will lower the required skill set that anyone can use now with AI. We would like to drastically reduce the human involvement in the process, and also to have a reliable and trustworthy platform. So at Applitools, we thought really hard about how we can take the good of both worlds and try to remove the bottlenecks and challenges that I just described. And we came up with a platform called Autonomous that now allows you to have a full test development platform at your fingertips. Sorry, ooh, that was loud. If you are testing a website, for example, or a multi-page web application, or a CMS, sorry, with our platform, what you can do is with one-click setup, we will validate the entire page. AI now can crawl across your UI, your website, and validate each page on its own. How will it do it? It will actually look for regressions between current versions and new versions. That's something that we can definitely do. It will also find for you broken links, errors, and network failures. To test anything beyond the website, we also allow you to describe custom test flows in plain English. You can write test steps in English on the left-hand side, as you can see over here, and they will be automatically executed on the browser, in the interactive browser, so you would be able to see what the AI is doing and to monitor it. As you can see over here, we just say type Adam Carmi in your name field. No selectors or locators are needed, and hence the test will be far more stable and will require less maintenance down the road. It will allow you to speed up the authoring by interacting directly with the page, or just perform the actions on the application itself, and then it will be translated to commands as well. Another important thing for any testing platform is the ability to debug it. Okay? So not only that you can write the test in plain English, and now anyone in the organization can see it and know exactly what it's supposed to do. We can also tell the platform to run this and that steps, edit them, and you get an immediate feedback about what the AI is doing. The more important thing is that we use AI only for the LLMs, the large language models, during the test authoring, when the human is involved in the process. Once the test was executed or created, every subsequent run, it will be determined steps each and every time. It will not have hallucinations. It will do exactly what you are seeing while you are building the test. How did we do that? The platform is 100% SaaS. So you don't need to install anything. There are no changes between your local machine to the machine that will run the test, network changes, cookies, and etc. that are the constant changes for those failures. As I said, LLMs use only for authoring. LLMs using heavily in the product, but only when we're authoring the steps. Because they operate on natural language, they perform much better than with test code. During test execution, no LLM is involved. Another thing that when it comes to functional testing and data-driven testing, Autonomous also allows you to do anything a developer can do with your coded test. If you need to have assertions, of course, we can verify that the text name field is capitalized or lowercase. You will have that in your hand. And you can see that I can just write it. I don't need to write any function. This is a simple example, not a complicated one. We can do test parameterization. As we can see over here, type name in your name field, and that's it. We can capture values in variables, extract values, execute JavaScript code, and everything you need to do to have the full flexibility to be creative and to get the test to do what you need it to do. Beyond textual assertions, Autonomous also allows you to have visual assertions powered by visual AI, which is by far the most advanced algorithms for visual testing. Visual AI is a large collection of computer vision algorithms that mimic the human eye and human brain. The way that it works is that actually every time that you're running a test, we're going to take a snapshot of the browser, of the app under test in different form sizes, browsers, and screen sizes, and compare it with the last approved version. We have a couple of customers in the crowd here that can justify about it. So when you're going to run the test, it actually will allow you to test beyond what you can imagine. For example, in this Wikipedia example, what we ask the test to do is to actually find regression on a static page. And it allows us to find here that the small and tiny icon had changed without that being noticed. Think about it. Who on earth would write a test that will validate such a icon change? I guess no one will, right? Just because it's really hard to find those and to think about all of them. But with visual AI, if it changed from what we approved it, we will find it now, okay? Okay. The next thing that we need to talk about is, wait a minute. It doesn't really behave as I expected. Perfect. The next thing that we need to talk about in testing is in scalable testing is the maintenance. Whenever changes do happen, we would like to minimize the level of maintenance that we need to do. So here AI will be involved again and will mimic your decisions. If you will see an icon change and accept it as the new behavior that you wish to see, then it will automatically propagate this decision to other tests that had this change to reduce the overload that's on the team. Another thing that we've added into the platform is the API testing. We would like you to be able to initiate HTTP requests. It is fully configurable, and it's really easy to author. those tests. So you can see here, send an HTTP request to this and that, and you will see in a moment how we can then debug the results, extract the results, and use them and validate them across the test. Here it is. You can see the structure of the results and then keep on building your test upon that. Okay, again, with no code at all and without selectors whatsoever. You can just use that along the way. LLMs are also assisting you in authoring the test itself. First and foremost, there is an error correction platform. It automatically corrects syntax and grammar mistakes. So if you say clack on something, it will change it to click on your name field. It also helps you with step simplification. If I will type below your name, click the field, it will actually write it in a meaningful way that later on anyone in the team will understand and change it to be click on the submit button. You can also write in other languages and it will also correct you. It also helps in step disambiguation. Wow, that's a tough word. Automatically disambiguate step to clarify how the step should execute. And above all that, there is a smart flow reuse. So for example, if I'm saying fill out the form or clear out the form, it will actually call the function that we created before that listed the fields that we need to clear to make sure that the team reuse the test that they created. I need to remember that I need to click this way, not here. So, yeah. Pretty cool, right? We can use LLMs, we can use AI without suffering from the hallucinations and the challenges that are embedded within it. How come? We took the power of AI only for the step of where the human being is part of the loop, when you author the test. Once we author the test and we created it, from that point on, the test is deterministic. It will always operate the same way as long as the app doesn't change, of course, right? Which is then what you want it to be. The main thing that I want you to take from it is that test automation doesn't need to be code first to be powerful. It needs to work, not to be in code necessarily. Okay? So, let's look on what we've talked about today. The traditional approach to test automation doesn't really scale. And the main bottleneck for it is the code itself. The fact that teams try to shift left to address this bottleneck, this code bottleneck, and shifting ownership to the teams that are, by definition, the more code-oriented in the organization, the developers themselves, is a proof for that. But in reality, what we've seen is that it just created even greater challenge because they are measured by other factors, and they have other inspirations to do it in mind. Then we've talked about the fact that the industry tried to react to this challenge by embracing AI tools that at the end of the day will just write more code, which is not necessarily that good. And we've heard about it. We've heard all about it in all the conversations over here. Why? Because we are in the testing mindset. We are all looking for those challenges in the code, right? AI is great in writing new code. It's great in writing unit testing. It's not that great in authoring, in editing existing code, in interacting with complicated environments. It hallucinates, which is the last thing that we can allow ourselves in testing. We also talked about that LLMs are not sufficiently reliable for executing tests at scale for all of those factors. And we've seen how taking the power of LLMs and removing the hallucination factors allows us to have efficient and reliable platform for doing testing. And we're at Applitools, at this platform. We've been doing that for the last 13 years. We've been doing AI for testing. Believe us, it's hard, but it's very much rewarding. Thank you very much for your time and for having me.
Any questions? Yes.
Hello, my name is Nikolai from WebPros. So what kind of approach do you actually use to make the test deterministic? Do you generate, I don't know, selectors, XPaths or something, or do you point to the point on the web page that needs to be clicked or something?
Amazing question. So the question, I'll just repeat on it. How do we make it deterministic, right? So remember that we've seen that the commands are saved in English. Click on this and that button. There is no Selenium behind the scenes. There is no Puppeteer or Cypress or anything like that behind the scenes. We're actually saving the intent, such as click on this button or fill out this form that you wrote. And then each and every time we'll learn the page, and we know what was the expected behavior in the last run, and we implement that. So even if the selector changes, or the location of the button is changed, we're constantly learning the page. For example, if we're talking about click on the submit button, we're searching for the submit button on the page. Okay? We're also using, one more argument, we're also using the selectors behind the scenes, and we have self-filling behind the scenes, but it's not Selenium per se behind the scenes. Did I answer your question, or partially?
Okay. Yeah. So if you're talking about learning behind the scenes or whatever, it implies that you are using some non-deterministic technology.
Correct. No. No. Okay, go on.
Basically, if you're capturing intent, you can use it to adjust your scenario later. But you cannot use it to produce deterministic results, because intent is not deterministic by its nature.
I got your point. So the way that it works is that when we have the intent or the command that you provided, we are learning what the button, let's say it was a click on a button, okay, just for having a convenient conversation, okay? So we are seeing what was the element that was clicked, and then we are trying to find it in different ways, okay? We have selectors in place that we have built-in self-filling capabilities on that, and we have other capabilities, also visual capabilities that we have on top of that, but it will always try to do the same thing for you.
Okay, so it's some kind of deterministic heuristic.
Yes.
Okay.
Yes.
Thanks.
We try to reduce the degree of freedom. Okay?
Okay. I think there isn't any more questions, but if any arise, feel free to contact.
We're at the booth.
Liran,
you're more than welcome.
Thank you, Liran.
Thank you very much.